solve an exercise that says find the y dx of y is equal to sine inverse of x and cos inverse of x. So this is inverse of trig function. So for we to solve this, we need to understand that y is equal to sine inverse of x is same as sine y is equals to x. Like this is same thing because remember that when we have something like sine y is equals to 0.5 and then I say find y, so we can say y is equals to sine inverse of 0.5, which might give us 30 degree. So this is same thing. So y is equals to sine inverse of x. Don't panic. You just take it, the sine inverse, return it how it should be in the first place. So at this moment, we are not trying to say that sine y is equals to x. Meaning in our trig, maybe we have a trig triangle this way, and let's assume this is our hypotenuse, not assuming this is our hypotenuse, and this is our y, the angle of y, this is our opposite, and this is our adjacent. Now, at this moment now, in our hypotenuse, remember that sine y is equal to x over 1, it means this is same as opposite over hypotenuse, if you're balancing it. So our opposite is therefore x, our hypotenuse is therefore 1. But we don't know what the adjacent is. And according to Pythagoras theory, it says that the hypotenuse square is equals to the opposite square plus the adjacent square. So the hypotenuse square, 1 square is 60 to give us 1, and we have this as our x square plus the adjacent square, which we don't know what it is. So when we take this, therefore, we're going to be having as 1 plus 1 is equals to x square plus the adjacent square. The collecting item, we're going to have something like the adjacent square is equals to 1 minus x square. Then the adjacent is therefore the root of 1 minus x square. Fine. Now, let's take this as our 1 minus root of this. So, at this moment here now, we have gotten something. So, therefore, let's differentiate it. Back to what we have. We have this as sine y is equals to x. So, when we differentiate the both sides, when you are differentiating sine, we are going to have cos y, then our dy over the x. Then when you are differentiating the x, you are going to have 1. So at the moment, let's divide both sides by the cos y. So when you divide both sides by cos y, you're going to have our dy over the x is therefore 1 over cos y. So 1 over cos y. From our table, from our trigonometric function, what is cos y? So from the trigonometric function, we have cos y is equals to, remember it is the adjacent over the hypotenuse. So therefore, what is our adjacent here? Our adjacent is the root of 1 minus x squared over the hypotenuse, which is 17 as 1. So when we divide this, we are going to get the root of 1 minus x squared. So let's plug it here. The y over the x is therefore 1 over the root of 1 minus x squared. The task we are doing this today is that try to solve the number 2, which is y is equals to cos inverse of x, and drop your answer in the comment section. And in our next class, we are going to be taking implicit form